Picture this, a swirling tapestry of light and color, galaxies spinning like cosmic pinwheels, nebulae glowing in ethereal reds and blues, and stars, billions upon billions of them, scattered across an infinite void. If the universe is expanding, what lies beyond its edge? The edge of the universe. The phrase alone stirs something primal in us, doesn't it? An ancient curiosity that has driven us to sail oceans, climb mountains, and send robots to distant planets. But here's the twist. The universe doesn't end the way a road might at a cliff's edge. There's no do not enter sign hanging in the blackness of space. What we call the observable universe is more like a cosmic bubble, our bubble, defined by the furthest reaches of light that has had time to reach us since the beginning of everything. Beyond that, well, we simply don't know. And that's the exhilarating part. This isn't just about distances too vast to comprehend or light too faint to detect. It's about confronting the ultimate question. What does everything really mean? So let's set off on a journey, one that takes us to the outermost limits of what we can see, and then dares to wonder what lies beyond. The universe is vast, mysterious, and above all, humbling. And as we peer into its depths, we discover something extraordinary. The more we know, the more we realize how much we have yet to learn. Imagine standing on a mountaintop with an endless horizon stretching before you. The farther you look, the more the distant peaks fade into the haze of the atmosphere. Now, scale that up to a cosmic level, and you get an idea of the observable universe, a bubble around us, defined by how far light has traveled since the dawn of time, some 13.8 billion years ago. Here's the catch. It's not a physical wall. It's a boundary of time. Light, that cosmic messenger, takes time to travel, and the farther an object is, the longer its light takes to reach us. So when we peer out into space, we're not just looking far, we're looking back in time, seeing galaxies as they were billions of years ago. This bubble of visibility, the observable universe, has a radius of about 46 billion light years. Wait, did you catch that? 46 billion light years. Yes, it's larger than the universe's age in years, because the universe itself has been expanding while light travels across it. Think of it as a cosmic balloon stretching over time, carrying those ancient photons farther and farther. But here's the humbling truth. No matter how powerful our telescopes get, there are parts of the universe we'll never see. Why? Because some light simply hasn't had enough time to reach us. Beyond the cosmic horizon, galaxies may exist, or may have existed long ago, but they're forever hidden in a curtain of darkness, receding faster than light can catch up due to the universe's expansion. Galaxies glowing faintly at the edge of visibility, their light dimming, stretched into oblivion by the relentless pull of cosmic expansion. Beyond that, only darkness, a void where light has yet to arrive, or may never arrive at all. This limitation doesn't just define what we can see, it shapes how we think about our place in the cosmos. Are we truly at the center of it all? Or is our observable universe just a tiny bubble in a much larger, unknowable reality? To make sense of this bubble, we've built some pretty incredible tools. Take the Hubble Space Telescope, for example. It's like a time machine, capturing images of galaxies so distant that their light began its journey billions of years ago. Hubble showed us that the universe is expanding, with galaxies racing away like fireworks after the Big Bang. And then there's the James Webb Space Telescope, JWST, a game changer. Positioned 1 million miles from Earth, it's peering deeper into the universe than ever before. Its infrared eyes can see through cosmic dust and pick up the faintest whispers of light from the earliest galaxies, shedding new light on the universe's infancy. These telescopes don't just extend our vision, they challenge our imagination. They remind us that our understanding of the universe is limited not by what's out there, but by the tools we have to see it and the questions we dare to ask. As we explore this observable bubble, one thing becomes clear. The universe we know is just a fraction of the cosmos that exists. Beyond the horizon lies the great unknown, and it beckons us to keep looking, keep wondering, and keep reaching for the stars. Imagine for a moment that our universe isn't the only one. What if it were just one bubble in a vast cosmic foam, with countless other bubbles floating alongside it? This is the heart of the multiverse hypothesis, a bold theory suggesting that multiple universes, each with its own laws of physics and unique characteristics, exist, separated by immense cosmic walls. In this grand picture, universes might collide, creating ripples in spacetime, or drift apart into eternal isolation. Our universe is a glowing sphere, one among many in an endless sea, each bubble shimmering with its own peculiarities, different physical constants, dimensions, and even alternate versions of reality. String theory, a framework attempting to unify all the forces of nature, adds an extra twist. It suggests that these universes could exist in higher dimensions, beyond what we can perceive. Picture a loaf of bread, where each slice represents a different universe, stacked and separated by an imperceptible barrier. Could there be other Earths, other stars, other beings wondering if they too are alone? The multiverse is as tantalizing as it is speculative. It challenges us to think beyond our cosmic bubble and consider the possibility that the edge of our universe might simply lead to another universe altogether. Now, let's stretch our minds even further. What if space has no edge, no boundary, just infinite expanse in every direction? This idea, though simple in concept, is profoundly unsettling. If space is infinite, then the galaxies we see are just the tiniest fraction of what exists. In an infinite universe, every possibility, no matter how unlikely, must occur somewhere. Somewhere out there could be another you, sitting in a parallel version of this very moment. Infinite space doesn't just expand the scale of the cosmos, it bends our understanding of probability, identity, and reality. To illustrate, picture the cosmos as a vast, endless plain, galaxies scattered like grains of sand on a cosmic beach. As the camera pans out, the beach stretches further and further, never reaching a shore. The implications are staggering. If the universe is infinite, it contains not just everything we know, but an endless array of everything we can imagine, and much more. But what if the edge of the universe doesn't lead to more space or another universe? What if it leads to nothing? Absolute, incomprehensible nothingness. This isn't just empty space, like the vacuum between stars. Space itself, the fabric of reality, ceases to exist. No matter, no energy, no dimensions. Just an absence so profound it defies human comprehension. A spacecraft drifting to the very edge of the observable universe, its instruments detecting nothing beyond. A blackness so complete it seems to swallow light itself. Imagine the unsettling sound of silence. No hum of engines, no cosmic background radiation, just a void. Philosophically, nothingness raises profound questions. Can nothing truly exist? Or is it a concept our minds have created to fill the gap in our understanding? Either way, contemplating such an absence is as awe-inspiring as it is unnerving. While these theories push the boundaries of imagination, one thing we know for certain is that the universe is expanding. Thanks to dark energy, a mysterious force making up about 70% of the cosmos, the universe is stretching at an ever-accelerating pace. As space expands, galaxies are carried along with it, like dots on a balloon being blown up. But here's the kicker. The further away a galaxy is, the faster it moves away from us. Beyond a certain point, galaxies recede faster than the speed of light, not because they're moving through space, but because space itself is expanding. This creates a practical boundary, a cosmic event horizon, beyond which light can never reach us. Galaxies drifting farther and farther apart until they fade into the distance, their light stretched into oblivion by the relentless pull of expansion. Eventually, only the closest galaxies will remain visible, and the universe will seem eerily empty. Dark energy, the driver of this expansion, is still one of the greatest mysteries in science. What is it? Where did it come from? And why is it accelerating the expansion of the universe? These questions remind us that the cosmos is as enigmatic as it is vast. From the possibility of infinite space to the eerie silence of nothingness, and from the mind-bending multiverse to the relentless expansion of dark energy, these theories paint a picture of a cosmos that defies human understanding. The edge of the universe is not a wall, but a doorway to what we cannot yet say. Each idea challenges the limits of what we know and teases the boundaries of what we can imagine. Whatever lies beyond, it invites us to keep asking, keep exploring, and above all, keep wondering. A spacecraft, the pinnacle of human engineering, silently drifting toward the edge of the observable universe. Its mission? To answer the question that has haunted humanity since we first gazed at the stars. What lies beyond? The probe's cameras capture the receding galaxies behind it, while ahead there is only darkness. But then, something strange happens. Instruments calibrated to detect the faintest signals from the cosmos begin to pick up something, a pulse. Regular, rhythmic, and utterly alien. It's not light, not radiation, not anything the engineers back on Earth had anticipated. The data streams back to mission control. An uncharted object emitting the signal is just beyond the edge of the cosmic horizon. Is it a beacon, a warning, or something more sinister? The probe ventures closer, its sensors struggling to process the data. Then, silence. The signal stops, and the spacecraft goes offline, leaving only a single image transmitted before the blackout. A faint shadow, stretching impossibly large against the void, with shapes and forms that defy comprehension. This speculative tale scratches at an ancient human fear, the unknown. The edge of the universe isn't just a boundary of light or time, it's the ultimate frontier of understanding, where the rules of reality may cease to apply. What if crossing that boundary reveals not answers, but questions too terrifying to contemplate? Imagine the experience of those explorers, their isolation absolute, with billions of light years separating them from home. The familiar laws of physics begin to distort. Time stretches, space warps, instruments give readings that make no sense, and then, one by one, they fail. The crew begins to experience vivid, shared hallucinations, visions of loved ones, lost moments, and an overwhelming presence that seems to watch them, just beyond their peripheral vision. Is it a trick of the mind? Or has something beyond the universe noticed their arrival? As the story unfolds, the fear becomes more tangible. The idea that humanity's thirst for knowledge may have led us to a place we were never meant to reach. A place where the universe itself whispers secrets too vast for our minds to grasp, where even our bravest explorers cannot return unchanged. Would we be ready to face what lies beyond? Are there some answers we should not seek? Cosmic horror isn't about monsters lurking in the shadows. It's about the overwhelming realization of how small and fragile we are. It's the fear of encountering something so vast, so alien, that it reduces everything we know to insignificance. So what if the edge of the universe isn't an end, but a beginning? A doorway to something far older and more powerful than we can comprehend? And more chillingly, what if it's not us crossing the threshold, but something else coming through? The edge of the universe isn't just a boundary, it's a mirror reflecting our deepest fears and greatest ambitions. Whether what we find will enlighten or destroy us is a question only the future can answer. Until then, the void beyond the cosmos will continue to haunt our dreams and our nightmares. Our quest to uncover the secrets of the universe's edge relies on ingenious methods and cutting-edge technology. To detect worlds beyond our solar system, exoplanets, we use techniques like the transit method and radial velocity method. The transit method is like catching a cosmic eclipse. Astronomers monitor a star's brightness and wait for a tiny, periodic dip. This occurs when a planet passes, or transits, in front of the star, blocking a fraction of its light. From these dimming patterns, we can deduce the planet's size, orbit, and sometimes even its atmospheric composition. Imagine this: a faint shadow, smaller than a pinprick, crossing the face of a distant star. That shadow tells us we're not alone. There are countless other worlds out there. Then there's the radial velocity method, often called the wobble method. As a planet orbits its star, Its gravity tugs the star ever so slightly, causing it to wobble. By analysing shifts in the star's light spectrum, tiny red and blue shifts, we can determine the mass of the planet and the shape of its orbit. These methods have uncovered thousands of exoplanets, some in the so-called habitable zone, where liquid water might exist. Beyond these, we're now detecting gravitational waves, ripples in space-time caused by massive cosmic events like black hole mergers. These waves carry information from regions of the universe hidden from light-based observation, offering a new window into the unseen. The future of space exploration is brimming with bold ideas and ambitious projects designed to push the boundaries of our knowledge. Consider Breakthrough Starshot, a revolutionary mission aiming to send tiny spacecraft to the nearest star system, Alpha Centauri. These spacecraft, propelled by powerful laser beams, could travel at 20% of the speed of light, reaching their destination in just a few decades. Once there, they could capture images and data from planets orbiting Proxima Centauri, potentially revealing habitable worlds or signs of life. And what about our eyes in the sky? Telescopes like the James Webb Space Telescope, JWST, are already transforming our understanding of the universe. But the future holds even greater promise. Upcoming projects like the Nancy Grace Roman Space Telescope will map the cosmos with unprecedented precision, searching for exoplanets and dark matter. Meanwhile, the Extremely Large Telescope, ELT, on Earth will use its 39-meter mirror to peer deeper into space, potentially spotting the first light of the universe. These missions aren't just about looking outward. They're about expanding the frontier of what's possible, bringing us closer to understanding the cosmos in ways we can't yet imagine. But even as we dream big, we must confront the reality that our tools and our understanding have limits. The universe is vast beyond comprehension, and our technology can only probe so far. Light fades, signals weaken, and cosmic distances stretch the very fabric of our imagination. Even our theories, our best attempts to explain the universe, may be incomplete. Concepts like dark energy and dark matter remind us how much we don't know. They're placeholders for phenomena that defy our understanding, accounting for 95% of the universe, yet remaining invisible and elusive. And what of the edge of the universe? No telescope, no spacecraft, no theory can definitively answer what lies beyond. Yet, this limitation is not a failure. It's a spark. It fuels our curiosity and drives us to keep searching, keep questioning, keep exploring. The tools of today may be primitive compared to what future generations will wield. They may look back at us, just as we do the early astronomers who thought the stars were fixed points on a celestial sphere, and marvel at how little we knew and how much we dared to imagine. In the end, science is not just about answers, it's about the journey. And as we stand at the edge of our understanding, the vast unknown beckons, urging us onward into the infinite. Let's pause and think about the word edge. In our everyday lives, edges are clear. The edge of a cliff, the shoreline of an ocean, the boundary of a map. They define where something ends and something else begins. But in the cosmos, edges are slippery concepts. If the universe is infinite, there is no edge in the conventional sense. No boundary, no wall, no final frontier. Instead, we find a horizon, determined not by the universe itself, but by the limits of what we can see. This raises a profound question. Is the edge of the universe a property of the cosmos, or is it a reflection of our own limitations as observers? The human mind craves boundaries. They give us a sense of scale, a framework to understand the incomprehensible. But what if the universe denies us this comfort? What if, in its vastness, it is boundless, an infinite expanse of stars, galaxies, and mysteries, stretching endlessly in all directions? In the face of such immensity, we're left to grapple with a paradox, to find meaning in a cosmos that might have no center, no edge, and no end. So what does this mean for us? If the universe has no edge, it challenges our very understanding of reality. We've spent millennia seeking to understand our place in the cosmos, drawing maps of stars, creating myths to explain the heavens, and building tools to extend our reach. But the more we learn, the smaller we seem. And yet, this isn't a story of insignificance. It's one of connection. Exploring the edges of the universe teaches us that we're part of something grander than ourselves, bound by the same forces that shape distant galaxies. It reminds us that the atoms in our bodies were forged in the hearts of stars, that our existence is intertwined with the cosmos in ways we are only beginning to understand. But there's another, more unsettling implication. If the universe has no edge, it forces us to confront the idea that there may be no ultimate answers, only ever-expanding questions. And if reality itself is infinite, what does that say about the nature of truth, existence, and our quest for understanding? Are we destined to forever chase horizons that retreat as we approach them? Here's the beautiful thing about being human. We don't stop looking. The boundless nature of the universe isn't a deterrent, it's an invitation. Every question we ask, every star we study, every probe we send into the void is an act of optimism. It's our way of saying, we may not know, but we want to understand. Hope and curiosity are written into our DNA. They're why we climbed mountains, sailed oceans, and eventually reached for the stars. And now, as we ponder the edges of the universe, those same qualities drive us forward. They remind us that the joy of discovery isn't in finding all the answers, it's in the pursuit itself. The universe is vast, mysterious, and humbling. It forces us to confront our smallness, but it also elevates us, showing us what we're capable of when we dare to imagine. As we continue to explore, we are not just charting the cosmos, we're defining who we are, as individuals, as a species, and as a part of something far greater. And so, the edge of the universe isn't just a boundary to be crossed, it's a mirror reflecting our deepest fears, greatest ambitions, and unshakable hope. The cosmos beckons, not because it has all the answers, but because it reminds us of the infinite possibilities of asking, what's next? In the end, we may never find the edge of the universe, but that's okay. The journey itself is enough to light the way forward. One star, one discovery, one question at a time. The edge of the universe, a concept that seems so simple at first glance, yet unravels into a tapestry of theories, mysteries, and boundless possibilities. From the observable universe, our cosmic bubble of light and time, to the tantalizing notion of multiverses, infinite space, and the eerie void of nothingness, each step of this journey has challenged the limits of our understanding. We've explored the tools and technologies pushing the boundaries of human exploration, the speculative horrors lurking in the great unknown, and the philosophical implications of an infinite cosmos. What's clear is this: the universe is not just vast, it's humbling. It doesn't merely invite our curiosity, it demands it. As we stand on the edge of what we know, we're reminded that our quest to understand the cosmos is as much about looking inward as it is about looking outward. It's not just the stars and galaxies that define the universe. It's our willingness to wonder, to question, to imagine. But what if the true mystery isn't in what lies beyond the universe's edge? What if the mystery is in how we imagine it? How do we frame our questions, interpret the unknown, and find meaning in an infinite cosmos?